This is problem 2 on practice exam 9 of chapter 1 in the book Problem Solving with Differential and Integral Calculus. There's a graph, y versus x. This is kind of a mathy problem because you don't know what the heck the variables mean. Provide a good estimate of delta y over delta x when x is 1. So x is 1 is right here. And then we want a good estimate of delta y when x equals 1 and delta x is 0.001. So over here, we go over 0.001. How far do we drop in the y direction? So let's start with A. We don't have the normal equation. It's not given. We don't know what it is. So we use the slope. We use the tangent line. Here's x equals 1. There's the point. And then we draw a good tangent line. That's pretty good. The rise, 3.95 or something. Run 1.77, 1.78, 3.9. I'm buying it. Goes down 3.9, 1.78 over. That looks good to me. Slope is minus 2.2. That's delta y over delta x. So that's the answer to part A. On to part B. What's delta y when we're at 1 and we go over 0.001? So delta y over delta x is minus 2.2. And we know what delta x is. It's 0.001. This is just a simple proportion. So we can solve for delta y. It drops 0.0022 when I go over 0.001 from 1. Starting at 1, going over 0.001. Part C. What's a good estimate of delta y over delta x when x equals 0? So x equals 0 is way up here. And we got to draw a good tangent line. How about that? The rise looks like minus 5.5. The run, 5, 6, 7, 8, 9, 9.4, maybe 9.3, 9.4. So the slope is minus 5.5 divided by 0.94, which is minus 5.85. That's delta y over delta x at x equals 0. The rate at which y changes with x at x equals 0. Part D asks for what's delta y when we go over 0.001. It should drop a lot more than it did at 1. We're here, we're going to go over to 0.001, and we want to know how far we dropped. There's the slope. Delta x is 0.001. We can calculate delta y. That's simple algebra, and it drops 0.585, 0.00585, which is more than twice as much as it did over here. If we had the normal equation, we would check, but we don't.